Nice, nice, nice. Okay, so everybody joining us on the live stream, I know people will pick it up slowly. So a few might have hopped on right away. They might have been waiting. We went ahead and pre-scheduled this on YouTube. So it has been up for maybe 3 or 4 hours. People could join it. So maybe, again, people, set their calendar or whatever to join as soon as this thing starts. And I know a lot of people are being notified within YouTube now. We have about 3,000 followers on YouTube, or 3,000 subscribers, subs, on our YouTube channel too. So they're all being notified now that the stream is going live. So they'll be joining, sort of jipping or joining in progress, JIPing. So everyone joining joining us remotely, wherever you happen to be, thank you very much for joining us. So this is the Open Source South Carolina Meetup group. I want to welcome everybody here. So everybody in person, it's great to see your face. Your faces look great. I don't mean that in a weird, creepy way, but God, do your faces look great. It's really, really nice to see you. So we've been away and out of the market and virtual for way too long. We've thoroughly enjoyed the experience. It's been a great experience. I will say that COVID threw us for a loop, like it probably threw most of you for a loop. There are days when I think, did that really happen? Holy crap. Did that really just happen? Even though it's now been almost 2.5 years. So we adjusted. We took all of our in-person programming and we shifted and transitioned to remote with the onset of COVID. It was a massive transition for us. We had never done a lot remotely. We had to learn it quick and really had to, again, kind of pick it up and adjust, like all of you had to adjust as well. Life changed for us in a very, very big way. So the bottom line is what we now do is we take more of a hybrid approach whenever we can. So we're happy to be back in person. It's really great to see your faces again, and I'll say that 7 more times before we leave. But it's also, what we're also trying to do is make remote or virtual content available to our community that can't make it in person, or they don't feel comfortable joining us in person, or whatever the case may be. So for everybody joining us remotely, thank you for joining. For all of you in person, thank you, thank you. For those of you that have attended an All Things Open event before, you know that I do have a tendency to overthink people, and here's why. As you get older, I'm now one of the older people in the room. There was a time not that long ago that I was the youngest person in the room, but that will happen to you too, all of you young whippersnappers out there. You will turn your head, close your eyes, and you will wake up, and time goes by fast, and you will slowly, gradually become the older person in the room like I have. So anyway, we're just very thankful that you're here. So as you get older, you've got less time left. At least this is the way it works for me. Fewer days left, less time less. I really am place a lot of importance on how I spend my time. I'm way more, I apply a filter now, and I'm very, very choosy as to how I spend my time. Whereas when I was younger, maybe not so much because I've got all this time left. But now I'm thinking, for me to go to something, it's got to be pretty good. I've got to get a lot of value out of it. So the fact that you've decided to join us here tonight really means a lot to us, and we just don't take that for granted. So I do want to thank you. And again, I'll thank you many, many more times before you leave. We are making swag available tonight. So now most of that swag is from ATO, but we also have some of the swag available from our sponsors. So it's over on the table back there, and I know people joining us remotely, virtually, can't see the table, so apologies for that. But for everybody here in person, I would encourage you to grab a shirt. We have accumulated inventory over the last 2 years. We've got a lot of shirts, a lot of hats, a lot of stickers, a lot of things to give away. Our shirts are pretty nice. Just ask anyone that has one. They're soft. We spend a lot of money on our shirts. They're shirts you'll actually wear. I've received many, many shirts over the course of my career. Honestly, I have never worn, and they went straight into the drawer, or even worse. We've made a conscious effort to spend more money on shirts. Again, really invest in shirts and swag and things that you'll actually use. So our hats are pretty cool, and our shirts are pretty nice. So I would encourage you to get one before you leave here tonight, okay? They're free. There are no strings attached. The only favor that we would ask is that you maybe let people know about our events, maybe let people know about us, make people in your network aware of maybe some of the events that we do here in town or wherever they might be. So that's the only favor that we have in exchange. So before you leave, make sure you grab something, okay? We would love for you to do that. And I know a couple of you already have here as well. I do want to thank our sponsors. Our sponsors are national sponsors. The first sponsor is Alma Linux. How many people here use Linux? Jim Salter is not allowed to raise his hand. Okay, very good. Okay, so Alma Linux actually supports a distribution or a distro of Linux. They're a nonprofit based out of California, and they really do great work. Alma Linux is a sponsor. I want to thank them. They're not here tonight, but I do definitely want to thank them. Camunda, CAMUNDA, Camunda.com. They're also a sponsor. They've got swag back on the back table. It's pretty cool. Be sure to check it out. And then Fidelity Investments as well. So everybody here has probably heard of Fidelity. I'll be honest, when I first encountered Fidelity and they first started attending our events, I thought, oh, they're an investment company, right? That's how I knew them. I'd never associated technology and open source technology with Fidelity Investments. That has changed massively for me now that I've gotten to know them as a company, and they are now long-term partners, and they've really been long-time partners of ours. So I do want to thank Fidelity Investments as well. I also want to thank a local company here too. Brooks, why don't you come on up? I'm going to yield the microphone here to a local business. One thing that we always try to do at our meetups, we try to do a lot of things, but one of the things that's a priority for us, come on up, Brooks, we try to highlight and feature local businesses that we think are pretty cool or that are doing good things that we want our audience and our community to be aware of. So Brooks, you're not only talking to people that are sitting in front of you, but you're also talking to people remotely and virtually. Right. And then we are recording tonight as well, so people will be able to watch this, the recorded version, even after tonight as well. But you've got a really cool business. You're headquartered here in Columbia, I believe, so we definitely want to yield the microphone to you for just a couple minutes.
Thank you so much. Hello, everybody. So my name is Brooks Bolin, and I founded a company called Minos Tech, which we go to market with a brand called MSP Disposal. My background is finance, actually. I used to work at a company called Unitrends here in town. So they're a software backup company who puts software on custom servers. And I solved a problem for them on what happens to the old stuff, and they eventually let me spin up a company on it, which is how the company started back in 2013. So what we do, the problem that we solve is everyone has a closet full of old computers, right? So how do you go to market to someone like that to pick that up, not incur any charge for it, and make money back and make sure all the data's been wiped? So our biggest core niche is called MSPs, so like a VC3 here in town. Imagine having 1,000 VC3s across the United States where these people have bins and boxes that we make and put on site, and when they are ready for these things to be picked up, they go into our UI. So one reason why we can scale really well is because we're also a software shop. I don't say that we're a recycling company. We can't scale globally through like Google migrations by just being local. So we have a team of developers that are writing code because we have a customer portal to where you can track the whole chain of custody on this thing was picked up, it was wiped to meet this DoD standard, and it was sold, because the goal is to give money back to the client, which they can see real time in the portal. So since we started the portal about 2 years ago, our customer base has gone from about 30 to about 1,250. We have no sales team. We have no marketing team. We drive everything primarily through trade shows. And it's just been a really fun past 2 years, a lot of work. We're really connected with the College of Computing at University of South Carolina, so we have up to 20 computing students that are doing all the work and the testing. We give them access to our software so our customers can actually feel that story, and they're giving back to the local community, and this intern's doing the work, and then we pay for their A+ certification. So I'll be around tonight if you have any questions, and feel free to ask.
Very cool. Brooks, thank you.
Yep, thanks.
I really, really appreciate that. So, yep, cool, man. So here's, I think, if I understand it correctly, the problem that you solve. And one of the reasons I wanted you to speak tonight is because I've heard so many people voice this concern. I've got all these old computers, or computers that we're no longer using. A lot of them include or contain sensitive data. How do I get rid of these things? Where do I take them? What's the process? Who can do this for me? I've heard so many companies voice that concern to me, just in a passive conversation, or maybe they're just like, Todd, do you know anybody? Now I do, right? Now I'll have a place to send them. But I've just heard a lot of people voice that problem. So again, if I can connect people that, people with an issue, people with a problem, to somebody that can solve it, I'll always do it. So when I heard about your company and you've started to work with us a little bit, I was just intrigued by the problem that you solved, because I know that a lot of people have the problem. I've even experienced the problem myself, and I did not know where to go. Now I do, but I didn't know before. But anyway, thank you. So if you've got computers, sensitive data, you now know where to go. And honestly, Brooks, I don't know what your competition is like. I've never heard of anybody else doing it. I'm sure you do have competition. I'm just not aware of it. You're one of the few companies doing that I'm aware of. That was another thing that made it really interesting to me. Yeah.
Next time we should have a booth here to collect old computers.
Yeah. What's driving a lot of our work now is actually Google migration. So if people go into public clouds, and these are 80,000, 50 petabyte deals, and that's why we have offices in the UK, we have offices in Canada, because data loss has to stay inside the country, which now means we have to be Google relevant.
Very interesting stuff. Thank you very much. All right, so if anyone wants to talk to Brooks, be sure to catch him before you leave or he leaves tonight. Okay, so I also want to make you aware, we do a lot of things. We host meetups, obviously. We're now getting back to in-person meetups here in Columbia. We also host a meetup, a really well-known meetup, one of the larger meetups in the RTP, or the Research Triangle Park in North Carolina. We host the Open Source 101 series. You know, open source technology is really interesting to us. We've now been in the space for 10 to 15 years. Open Source 101, right, it's akin to a 101 university class. It's viewed as an on-ramp into open source. We host that series for people that are on-ramping into the space. And we also host All Things Open. All Things Open is the largest event, one of the largest events, technology events on the East Coast of the US. We host that every fall in Raleigh in the Research Triangle Park in October. This year it'll be October 30th through November the 2nd. How many of you here have attended All Things Open before? Okay, more people than I thought. Thank you all. On behalf of our team, thank you for attending. If you haven't attended, I would encourage you to do so. The last 2 years have been funky. Been weird. It's been weird for everybody with COVID. Last year was pretty good. It was hybrid. We had about 1,000 people that joined us in person, about 3,000 or 4,000 people, 5,000 people that joined us remotely. In 2020, we were all remote due to COVID, obviously. This year, we think we're going to be closer to 2019 in the before times than 2020 or 2021. So in 2019, we had about 5,000 people that joined us in Raleigh from all over the world. Highly sophisticated audience. Some of the best known technologists in the world joined us in Raleigh. They either spoke, they attended, they sponsored, they were just there, they were available. People that write books, numerous authors did book signings. We made a ton of books available for free, et cetera. So I would encourage you to join us in Raleigh. Go to allthingsopen.org. You can see everything that we do. I would really love for you to do that. Okay, fair enough. Everybody joining us remotely. Most of you have already heard of All Things Open by definition, or you wouldn't be here. But I would still check out the website, allthingsopen.org, to see everything that we're doing. We're updating that website, and we would love to have your support. Okay, so with all that said, I've got about 6:40. Jim Salter is going to follow Veer. Veer is going to be our first speaker. We're going to nerd out a little bit tonight, if that's okay. I know most of you, that's music to your ears. Some of you might say, I don't know about all that. But do stick around. Veer is one of the... In my opinion, just my opinion, I think he's one of the best technologists on planet Earth. He's been in this space for a long time. He made the trip over from Atlanta. Veer's been a multi-year speaker for us at the All Things Open event. Veer, have you ever been a speaker at Open Source 101? I think you have virtually. You did virtually. Okay. So for us to ask speakers to come back year after year, I don't know, you got to be pretty good. I mean, you really have to deliver value to our attendees, and Veer's done that. Jim Salter will be our second speaker tonight. Jim's going to do a demo. He's going to demo an open source project that he started maybe 3 or 4 years ago, Jim, or maybe 5 years ago or something like that, called Cyanoid. What we're trying to do at our meetups is not only highlight local businesses, local companies, feature a really cool tech talk, but we're also looking to highlight case studies or open source projects that are just really cool. So we wanted Jim, who is local, actually lives in West Columbia, to actually come in and demo this open source project called Cyanoid that's proven to be extremely popular, lots of contributors from all over the world, et cetera, et cetera. So Jim will follow Veer, and we're going to try to have you out of here by 8 o'clock. Everybody joining virtually, we should be wrapped up. Our goal is to have all of this wrapped up in about an hour and 15 minutes or so. Okay, is that fair? Any questions from you? Any questions from the audience? Y'all have any questions before I yield the mic to Veer? Excuse me. No? Okay. Thank you all again for being here, right? I told you, I warned you I would sneak a few more in on you, okay? And I'll sneak about 10 more in on you before we wrap up tonight. Veer, with all that said, here's what I'm going to do. Hold that microphone. And yes, I'm actually doing this. There you go. I might have spit on that microphone. I don't know.
Thank you. Wow. So I think this is one of the first, I would not say the first event after things opened up, but this is one of the first most attended event, I would say. So welcome. My name is Veer Muchandi. I work for Google Cloud. I'm an app mod solution manager. What that means, we build solutions that are cutting across multiple industries with technologies that come from Google as well as with open source technologies put together. When I say solutions, There are products that Google comes out with, but each product has its own area of concern, right? What we try to do is, rather than coming and telling you, hey, buy this product, we say, hey, here is how your problem is solved, your business problem is solved by putting these technologies together, and here is how you can apply them, right? So we are looking at business use cases and applying technologies to solve those business use cases. So the solution that we are today talking about is inner loop application development and how we can speed it up. Specifically, we are talking about inner loop development with containers. Quick question, how many of you are developers? A bunch of you. Oh, nice, good. So this is for you. Yeah, so this is a solution that, are you container developers? Do you use containers? No, not yet, okay. But are you thinking about moving to containers? Containers, Docker, Kubernetes, yeah? Most of the enterprises are. So if you're not using it, you know how to use it using after this session, right? How to do application development using containers after this session. And if you are already using containers, maybe you will learn how to make it faster, right? That's the value we can provide with this session. So let's get started. So I'll set the context of what this solution is about, and then we'll talk about, we'll actually understand what the inner loop problems are. We'll first understand what inner loop is, and then we'll get to inner loop problems. Then we'll talk about how to solve those problems with the solution that I'm proposing. And after that, we'll also have a demo of that solution, a working demo. So context. Those of you who are developers, what do you do every day? You have your developer workstation, you write your code, you test it locally on your workstation, you build it, and you test it locally. And typically, none of us are, I would say, do it right for the first time. So we keep on doing it for the whole day, right? Write code, make some changes, build it, test it, make some changes, build it, test it. Once we are happy with our changes, that's when we push our changes to a source control repository. Do you all do that? Yeah. So the thing that happens on your workstation, before you're comfortable with your code to push into a source control repository, that loop that runs on your workstation where you are writing code, building and testing n number of times in a day, that's inner loop. Once you push the code to the source control repository, either by a manual trigger or an automatic trigger, the next set of processes start out. What is that? That is where you are actually integrating code from multiple developers, right? So you are always working in a team, right? There are a bunch of developers coming together. Each one is writing their own code. Everybody's code gets into the same source control repository, and that entire code needs to be integrated, and then it has to be built, put into a integrated development environment, gets tested there, and after that it goes into higher environments like QA, staging, and production. That entire thing that happens after your code gets into the source control repository, that happens as part of CI/CD infrastructure, continuous integration, continuous deployment infrastructure, right? And the code gets pushed into higher environments, which are managed by platform teams. So when you think about who are involved in the inner loop is mainly for the application developers, and the outer loop is for the DevOps teams, right? Do you all agree with me? How many of you, I asked you how many of you are developers. Are there any DevOps people here? Operations, DevOps? A couple of you? Yeah, yeah. So you mainly deal with the outer loop part of the house, right? So now if we divide it this way, our focus for today is on the inner loop. So sorry guys, I didn't mean to cut you off, but we have a solution for that as well. Maybe in the next session, I'll talk about outer loop, okay? Today, our focus is inner loop. Having said that, you'll also see how things can be improved in the inner loop, because most of the operations teams are also concerned about certain things that happen in the inner loop, okay? So let's see. So let's understand what problems we have in inner loop. This area has been ignored for quite some time. Although we have these problems, people acknowledge those problems, but they just move on. Nobody focuses on inner loop problems. And we are going to look at those problems and focus on them today. What kind of issues? We are going back to the guys who manage outer loop, right? Operations teams, platform administrators, security teams. What kind of things do they talk? Do they say, right? When they are setting up your workstations, your developer workstations on which you are actually writing code, the security teams talk about source code on a workstation being an exfiltration risk. Are you facing these kind of problems in your organization? Yeah? So I don't want the code to be downloaded because nowadays, especially in COVID, right, everyone is working from wherever they are. If the machine gets stolen, code goes, and you actually, people who steal can actually steal the IP that comes along with the code, right? It's becoming a bigger and bigger problem in the current context. Security is very, very worried about that. Problem number one. Other, downloading test data is a security risk as well, right? Think about offshore, right? It becomes even more complicated when people are working from a different country. That's where this problem is. Third, the security teams are doing more and more to restrict the laptops. This machine, it's not allowed to access anything from outside. I cannot copy things outside, or I cannot copy things from outside to this machine or from this machine to outside. That's how the restrictions are of it, right? Every organization is learning over a period of time, but they're actually restricting the developers' workstations. Infrastructure administrators, people who are actually making the infrastructure available to you, right? They are also making, these are not people who are just setting up the servers, they are also setting up machines and laptops available to you. It's shipping delays. If you have a new developer starting on your team, how long does it take for them to get a machine set up, fully ready, operational? It takes several weeks, right? So even if they have a laptop, let's say, or a desktop, whatever that is, how long does it take to set up their environment, set up all the dependencies, and get them operational? Quite some time, right? The developer productivity is very, very low in the first few weeks, even though the developer is on the team. That's one of the problems. Onboarding delays. Then they are actually asking for, can everything be on cloud? Can I do VDI? Right? But you know how painful VDI is. Has anyone used VDI? You did? Do you like it? Yeah. All right. So remote developers. Now this could be, earlier we would call these as offshore developers, but now any developer who is working remotely from home, at least, or even hybrid people, like people who are going to work a couple of days in a week and rest of the times they are working from home. These are all remote developers, right? VDI is slow and painful. He doesn't agree with me, but yeah, anyway. Yeah. If you want to spend money, right? That's the challenge there. Being offshore, this is specifically for offshore developers. They are not allowed to download source code. They have to work on a remote VM and think about network connectivity from the other side of the world. Builds take too long because these machines are smaller, right? It's painful to run a build, and they can just start a build and then go take coffee and come back. Hopefully the build is complete by then. Again, the same exact question. I wish my workstation was on clouds and I am able to access from anywhere I am, right? That kind of a requirement is coming. I mean, these problems are not designed by me. These are actually coming from the customers that we have spoken to. All right, next. Container-based application development. Those of you who are using containers in production, right? Think of how the application development is happening on the developer's workstation today. There are two different scenarios. In the first scenario, the container developers are not actually using containers. What they're doing is traditional application development, where they write the code, compile it, create a binary. Let's say they are writing Java code. Then they run Maven build or Gradle build, create a binary, which is a jar file or WAR file, test it locally. Probably they deploy it on Tomcat, test it locally, and then that loop repeats. And once they are happy, they push that into the source control repository, right? Same thing with any other language. Now, in this entire process, there is no containers at all, right? So what happens is containers actually get created in the outer loop. Once the source code is pushed into the source control repository, then the CI/CD process triggers the first diagram. Remember that? The outer loop? That's where the containers get created and get deployed into higher environments. What does that mean? It means your dev is not in sync with production at all, right? So there are issues that come up later in the life cycle where devs they think they are not responsible for those. Make sense? Okay. Let's look at another scenario where containers are actually being used by developers in their local environment on the developer workstation. What's the problem here? Here, think about what all they do. Again, they write their code in their favorite IDE. Then after writing the code, they test it normally by creating a binary, let's say Maven build, and test it locally. Once they do that, again, they have to create a container, which means they have to use a Docker file, run a Docker build, create a container, deploy that container, so Docker run, and then test it on their local machine. If they are happy, it goes through. If not, again, it goes through the loop. How long does it take for that to happen? So many steps, right? It takes so many minutes. Now you have to switch from IDE to CLI, learn so many different tools, and only then, and for every code change, you make a small code change, you have to go through this entire process. I myself tested this for a Node.js application. It took about 9 minutes for every cycle. Think about it, right? So that's a problem here. It's slow. And IDE integration is a challenge because your IDE is different. You have to switch between IDE and CLI. People don't like it, right? In spite of doing all this, if you are using Kubernetes in production, which is common, right? If you are doing container-based application development, you are actually deploying into Kubernetes. All other container technologies are gone. Only Kubernetes survived, right, today. So if you are deploying this into Kubernetes, locally you are testing with just Docker run, but in production you are using Kubernetes, you are still not matching with production. That's another problem. Do the problems that I just explained make sense? Yeah? All right. Now, what are the other issues? A few more. How do I debug my code if it is containerized and I'm running and I have an issue? Can I do step-by-step debugging? Is it even possible? Most of the organizations don't know that it is possible. It is actually possible, and we'll see that. How do I, when I'm building containerized applications, typically these are small microservices. And when you're writing a microservice, you are typically integrating with n number of other microservices. So you are now talking about 10 different services running together. So how do I test by integrating with these other microservices? People typically write their own service, test it locally with their own service, but they are not testing with other microservices because they don't know how to do it. And their workstation doesn't support running so many services at the same time. How do we deal with that issue? That's another problem. Next, we talked about Docker and Docker files. I'm a simple Java developer or a Node.js developer. I know how to take business requirements and write my code. I don't know all these other layers in the Docker file. How do I deal with it? I don't think I should be responsible for which operating system library goes into the file. which other layers should be included in the Docker file? Why am I responsible for things that are not in my control? Fair question, right? So developers don't want to be responsible for things that are not their skill set. Make sense? All right. So that's another issue. So what is the solution? We talked about so many problems, but is there a solution for all this, right? That is where this solution comes into play. We want to speed up the container development inner loop by reducing the number of steps. You see all that write code, compile. This is exactly what I explained before. We want to go from there to simple write code. Don't get out of your IDE. Compile and containerize while you are in the IDE itself. I don't want to learn Docker. I don't want to run how to containerize. I don't want to write Docker files even. Just create the containers, deploy it onto Kubernetes, as well as I want to test it while it is running as containers on Kubernetes, right? We want to reduce the number of steps in the inner loop to reduce the amount of time it takes for each cycle of inner loop, okay? We want to bring it down from minutes to seconds. That's what this solution provides. What are the features of this solution? First, we will be hot reloading the changes. Any change that you make in your IDE will be immediately visible in your running container on Kubernetes. That's called hot reloading. We'll see how that can be done. Second, IDE integration. That means you don't have to leave your container, your IDE and get to CLI and then switch between this context and all that to test your application. It will be fully integrated into IDE. Third, you can debug your code, step-by-step debugging of your code from IDE itself. Fourth, you want to use the same exact Kubernetes that is used in production in your development as well. Okay? Fifth, integrating with other services. It could be other microservices, or it could be other services such as databases and all that. Maybe databases, maybe PubSub. Anything that your application uses as an external service, you want to integrate with it and test it right away before your code goes out of your workstation. Right? How do we do all this? That is what the solution is about. So and then code to container. You write your code. I don't want to worry about Docker files and all that stuff. Let the system take care of it to convert my code into a container and deploy. Okay, can we do that? Yes, let's think about it. So the process is write your code, compile, build a container, deploy it into Kubernetes, hot reload the code changes, test it directly on Kubernetes, right? Kubernetes is production like Kubernetes. And then come back, and within few seconds, if you want to make a code change, yeah, make it, and it is immediately available to see in your Kubernetes cluster. That's the solution. So what products are involved in this, and what do they do? Let's think about it. The first one is a cloud-based IDE called Cloud Shell Editor. This is a free tool. It's available on Google Cloud. Just go and, if you have a Google account, for example, just go and open a Google project. Click on the top. There is, I'll show you where it comes up. Click on the top, there is an editor, there is a Cloud Shell. Click on that Cloud Shell, it opens up, and there is an editor also that comes along with it. It looks just like VS Code. How many of you have used VS Code? Yeah, okay. So then you are used to that interface. It's based on Eclipse Thea, and the same exact interface is what you get, and all the VS Code plugins work with that as well, right? It's called Cloud Shell Editor. That is what we are promoting. You may ask me a question. Can I actually use VS Code or IntelliJ or PyCharm? I mean, depending on whichever editor you are using, can I not just continue to use that? Yes, you can use it with the same exact solution. But this other problem of workstations being shipped and all that stuff, those will still remain if you don't want to use a cloud-based editor. Use what you're comfortable with, but you have an option, and if you are using the entire solution, we are promoting the Cloud Shell Editor because it will reduce the burden on those folks standing there. Okay? All right. Second, runtime integration with the from the IDE to your Kubernetes, both for writing your code and debugging. Who does that? That's where an extension called, or a plugin called Cloud Code comes into play. This Cloud Code extension is pre-installed onto the Cloud Shell editor. But if you want to run it in your own IDE, let's say on VS Code or IntelliJ, you just need to install it. Okay? Next, there is an open source project called Scaffold. This is backed by Google in the sense there are Google engineers working on that Scaffold open source project. And that helps you do that hot reloading of your code from your IDE directly into a running container. Okay? That's another technology we'll be using in this. Then, the actual runtime would be a Kubernetes cluster. It is GKE, for example, Google Kubernetes Engine, which is Kubernetes supported by Google. You can use any Kubernetes engine, by the way. But the one we are talking about, the example that we are going to look at, the demo we are going to look at, will be using Kubernetes. Or you can be using serverless environments too, like Cloud Run, right? Or you can, if you want to use Minikube, you can. But again, there are some constraints when you use Minikube. Like, if you use Minikube, the resources on that workstation, how much capacity you have on that workstation, will limit what you can run on that box. So for example, if you want to run 10 different microservices and test, it may be a challenge when you are using Minikube. So that's the reason why we are promoting using an actual runtime that is very similar to production, like a GKE cluster. Make sense? All right. Any questions so far? Okay, good with me. Right. So let's talk a little bit more about Cloud Code. Cloud Code is an extension that goes on the top of your favorite editor, right? And it allows you to write your code, deploy it directly onto Kubernetes. It also streams logs from your running container back to your IDE, and you can also debug. You can do step-by-step debugging directly from your IDE into a running container. And I'll show you an example of how to do that. Next, it's integrated well into your IDE. Just install that extension, and it looks like, let's see, looks like this. Right? It's an extension that is, once it is installed, it looks like that on your editor. So what does it do? It allows you to deploy your applications directly from your editor. So you don't have to leave the editor. Just write the code, press a button, and it gets deployed, or run a command, and it gets deployed. And it has seamless integration with that other technology that I talked about, the Scaffold, that open source project, that is well integrated into this extension. Let's think about Scaffold itself. Scaffold, as I said, it's an open source technology. It does a bunch of things. We are only going to focus on one particular thing. What does it do? It allows you to do continuous development and debugging. That syncing of code from your IDE to a container is handled by Scaffold with just one flag. That is called continuous development and debugging. In addition to that, it also deals with CI and CD. So for the DevOps folks here, they can also use the same exact Scaffold for their later stages of the application development lifecycle for CI and CD. But today, our focus is going to be on the continuous development and debugging using Scaffold. Okay? So how does all this come together with Scaffold? Scaffold is a glue between your IDE and your running container. How does this all come together? So think about it. You are a developer, and you are on the workstation, right? This could be a cloud-based workstation, or this could be your local machine. It doesn't matter. You are writing the code on that, and you have Cloud Code extension on that. Okay? Now, you wrote your code. The first time you deploy the code, what happens? This is the first time it actually builds the code, creates a container. You can do unit testing if you want. Not if you want. Do unit testing all the time. Okay. And then deploy that code onto Kubernetes. That means that's when the running container comes up on Kubernetes as a pod. Good? This time, the first time, the process takes longer. It takes those few minutes that I talked about before because you are actually building a container and deploying it. That's only the first time. After that, what Scaffold does is it streams the pod logs, the logs for your application that are inside your container. It streams it directly back to your editor, your IDE. You don't have to do kubectl, logs, pod name, and before that you need to find the pod name and all that, all those 10 different commands you need to learn. No, not needed. It comes directly into your IDE, and you can see what's going on for your running application, right? And then the next step is it syncs, it watches what changes you are making in your editor. So you're running your application, you're testing, you don't like this heading, you went and made a small code change to change the heading. The Scaffold is watching those changes. As soon as you make a change, it syncs that file back into the running container. So within a few seconds, your changes are available. Those few seconds also depend on which technology you are using. Let's say you are using Spring Boot. At a minimum, in order to load your code changes, your Spring needs to restart. It takes a few seconds. But if you are using other technologies like, let's say, Node.js, it doesn't take that long. It immediately, like within a second, by the time you notice, your changes are available. Make sense? All right. So let's think about runtime now. We are coming to the right side, runtime. If you are using GKE as your runtime, your Kubernetes engine as your runtime, this is same as what is in production, right? How does this all come together? Like, do I need does every developer need their own Kubernetes cluster? Or can I create one cluster and share among all the developers in my team? Both possibilities exist. For example, if you are using GKE, we have something called GKE Autopilot, where you are only paying for what you are actually using. If you are using one pod, you pay only for one pod. So you're not actually losing anything by spinning up a GKE cluster for each developer, if you have to. But the practice that is working well with the organizations that are actually adopting this approach is that they spin up one GKE cluster per team, and they create a namespace within that GKE cluster for each developer. So each developer gets an allocation of a namespace with a specific quota, and they can spin up n number of pods with X amount of CPU, X amount of memory, kind of, right? So they are limited to how much they can use, but each one gets their own namespace. Now think about it. They can actually spin up an entire application in their own namespace and deploy this particular microservice that they are building and test it with that, right? So rather than trying to do it on your workstation where you have limited capacity, you have much bigger capacity that you can increase if you have to on an actual Kubernetes cluster, and this is going to match production as well. So that means you can do integration testing well within your inner loop. You are moving your integration testing to the left. Rather than doing it only in the outer loop, you are moving to the left. What is the advantage of moving it to the left? Cost savings, right? You are realizing issues with integration much earlier in your life cycle, which means you are going to save the costs. Make sense? So you can also integrate with other services. Like, for example, if you are using a database, you can integrate with a database using a private IP because you are running your application on a Kubernetes cluster, and it has connectivity to your database over your VPC connection, and you can test it. So your testing, the scope of your testing as a developer increases a lot. You can actually discover all the issues that you would have found later in the life cycle will all be known to you much in advance. That means you are becoming better and better developers. Operations folks are going to be happy with you. What else do you want? Right? Okay. Next, what if I am using Minikube instead of a GKE cluster? Can I do that? Yes, you can. Minikube will run on your workstation itself. So if you are using cloud-based workstation, Minikube will run on cloud-based workstation. If you are using your local desktop as your workstation, Minikube will run on your local desktop. But the capacity of what you can do there will be limited by how big your machine is, right? So resources are constrained. Every developer will have their own Minikube. So now let's say you want to test it with a database. You need to provide a public IP to the database so that you can connect it from your Minikube instance, which is a security issue, which your platform operations teams or your database administrators may not agree to do that. Make sense? So that's the reason why the other solution is better than this. But it is possible. So let's get to the demo. You understood how the solution works. Let's see it live. Okay? It's going to be hard for me to both hold the mic and do the demo at the same time, so I'll try to jumble. Okay. All right, what you're seeing here is the Cloud Shell editor that I talked about before. So if you are in a Google project, you click on this button on the top, and it will activate Cloud Shell. And after it activates the Cloud Shell, there is this editor thing here. If you click on this, it will open the Cloud Shell editor. I already did it, so I don't want to close it again and do it. So basically, or maybe I'll do it. So it will be like this, a regular terminal. And if you click on this open editor, then the editor comes up. I'm going to close this lower part and just use the editor. So I have a blank editor. The app is not there. What I did for the sake of time here is I went into spring.io and downloaded a simple Hello World Spring Boot application code from there. So just simple Hello World to begin with. And I made a few changes. I could have done all those things live, but it would have taken like 20 minutes more, which I wanted to avoid. So what I'm going to do is get my code from my GitHub. This is the same exact Spring Boot Hello World application downloaded from spring.io, but with a few minor changes, and I'll show you what those changes are. I clone the code, so I should have a new folder. Let's see. Open folder, Spring Boot Hello World, hot reload. Open this. This is a cloud-based editor, and it looks very much like VS Code. The user interface, the look and feel, and the speed at which it operates is also like VS Code. Let's look at what changes I made. First, I took the default pom.xml file. How many of you are Java developers? None? Oh, so maybe I picked up a wrong example. How many of you are Node.js developers? At least a couple. Okay. And Python? Couple. Okay. So if you want to do this yourself in your favorite language like Node.js or Python, I do have these labs available, but we'll talk about that a little later. Let me show you Java. What I did first is, since I prepared for this, it's hard to immediately switch to a different technology. So I'll just continue with this. All I did here is I created a profile for this sync ID, sync profile, right? And I said, hey, I'm going to use Spring Boot developer tools if you are using sync ID. The other thing I did is added a couple of plugins. One is a Jib Maven plugin. This Jib is the technology which allows you to create a container without using a Docker file. So if you, and similar things are available for Node.js and Python as well. So basically, you see here that there is no Docker file in the code. Without using Docker, we are going to create a container. And Jib does that magic. There is So that's it here. And then I created a scaffold file. We talked enough about scaffold earlier. And the scaffold file, it handles both the build and deployment to Kubernetes. Build points to an image with this name, my Spring Boot app, right? This is the image that gets created, the container image that gets created. And it uses Maven to do the build. The arguments, you see that it is using a profile sync, and that's the reason why I had to create sync profile in that pom.xml file. It starts with this base image, which is a distroless base image, Java base image. Distroless base images are pretty small. They don't have all the junk. They are just limited to very, very simple base images, right? They don't have things that you don't need in production. The most important thing here is the sync auto equal to true. This is the one that does sync your code from your IDE. So if I make any code changes here in the IDE, this flag allows me to sync those changes all the way to the container running on Kubernetes once it is deployed. As of now, it is not deployed yet. The next section, this is the deploy section. It is using kubectl. Kubectl is Kubernetes' the command line for Kubernetes, right? Using kubectl, it actually will deploy the contents of this deployment.yaml file. Let's look at what is there in this deployment YAML file. There is a simple Kubernetes service and Kubernetes deployment, right? And this deployment is pointing to the same image that Scaffold is creating, my Spring Boot app. So it will deploy an application using this image, and the app will be named as my Spring Boot app. Okay? So those are the changes I made. I created a scaffold.yaml file, I created a deployment.yaml file, and I edited the pom.xml file, just to save 10 minutes. Okay? Now let's see how this works. So Cloud Code extension, Cloud Code is that plugin that I talked about. It is already installed. When I click on this, it opens up a menu of what you can do. I'll say, run this application on Kubernetes, and see what happens in the output underneath. It is trying to build this application, but before that, I'm going to create a container image using Jib. So where do I save that container image is what it is asking. So by default, it is pointing to Google Container Registry, GCR, and it's looking at this repository, which is same as my Google project name, and I'll just accept what it is given by default. I want to put it there. Now let's look at what it does in the detail logs. It starts this scaffold to do the build of a container. So scaffold goes and runs a Jib build. So it is running, Jib is using Maven to build the jar file. And after that, it created a container, pushed that container into GCR, which is the container registry. And after pushing that container into container registry, it uses kubectl to run the deployment. So it deployed Kubernetes service and a pod. Now, after deploying that service, it's moving forward actually, so I'm going back. After deploying the service and after deploying the pod, it is actually doing streaming of those pod logs. So see the streaming logs from the pod. So it created a pod by this name, and it is streaming the pod logs here, right? So how is it doing that? Actually, one of the things I missed telling you is one additional thing I did is I created a Kubernetes cluster in advance, and I connected to that cluster from the IDE. In the IDE, these are all Cloud Code extensions. There is a Kubernetes extension here, and here, if I press on this plus sign, I can add a new cluster. If a cluster already exists, I can just connect to an existing cluster. So now a pod is running in this cluster. This My Spring Boot app is the pod that got just deployed. So let's see. Age 1 minute, right? It just got deployed. So it took some time to deploy this, right? It took a few minutes for us to build that container and start running. And we saw how long it took. Now, let's look at the run debug logs. Here, it also provides a URL to access our application. How do I test this application? It gives a URL, and let's open this in web preview. It says greetings from Spring Boot. This is the default Hello World application. No big deal. Let's go back and look at the code. It has a simple hello controller which says greetings from Spring Boot, right? Now let's say I change the code, okay? See what happens here. At the bottom of the screen, it says it is watching for changes, right? So let's say I change this to hello, hard to type with one hand. And as of now, I'm in the same line. Watch what happens when I click somewhere else. You see that file sync started? One file got synced. Let's look at the detail logs. Oops, I think it did a lot of things by the time we went there. It synced the files, and it restarted Spring Boot, right? And changes are available here. So do you see the difference? It didn't have to build the entire container. As soon as I made the change, it is immediately available. Let's say hello, South Carolina. One more change, just. Right? As soon as I make the change, it is restarting Spring Boot. Hello, South Carolina. Make sense? So we brought down the inner loop time from a few minutes that it took earlier to just a couple of seconds. See the difference? So, yeah. Now let's look at, you may say, hey, this is a simple hello world application. How does it matter to me? Can we do these things in a complex application, decently complex enough app, right? Let's complicate it. We'll take the same code, right? Assume that I'm a developer and I want to actually do some real coding, okay? 5 more minutes and we'll be done. So what I'm going to do is add a couple of files. We are going to convert this simple hello world application into a CRUD application. What is CRUD? Anyone? Louder. Yeah, create, read, update, delete. So it can connect to a database, do create, read, update, delete. Okay. All right. In order to build a CRUD application, I need to add a folder here. Hard to see. New folder, resources, and I'll add a properties file, application.properties. And by the way, I'll stop this thing that is running because it picks up every change. And in that application.properties file, I'll add some connection parameters. Right? So these connection parameters will tell the Spring Boot that if you want to connect to a PostgreSQL database, you should use this approach, a JDBC connection, using so-and-so variables. But where are we going to fill these variables? They need to come from outside, right? So Kubernetes, in the Kubernetes deployment, will add the values for these variables. So what I'm going to do now is edit the deployment file and provide the values for these variables. So go to the Kubernetes deployment. And add the variables. So I'm connecting to a database host with this private IP address. So in support, username, password, and all, these are coming from a Kubernetes secret. Okay? Right way of doing it. Put it in secrets. Then I need to change the pom.xml to be able to connect to the database. I would add a couple of additional dependencies, and these dependencies are JPA for Hibernate, for using Hibernate. I'm using JPA to use Hibernate, and I'm giving a PostgreSQL dependency so that I can talk to a PostgreSQL database. Do I need to hold this? Yeah, I'll do that. All right, and then now let's add the actual code. I'm not going to write all the code because we just have 5 minutes. I'll just upload the code that I already wrote. Okay. So I added an entity class. This has a few parameters, getters and setters. And I have a controller. This does get and post. You all know REST, right? Get is get, and post is if you want to add new data. That's what I'm adding here. All right. So this shows that there are some errors here, isn't it? Let's quick fix them. The reason I put these errors in there is to show you that this works like any regular editor. Although you are using it in cloud, it's like a regular editor, right? It does everything that that Visual Studio Visual Studio Code does for you, right? So now that our code is ready, let's run this application again. I'm starting from cold deployment, so it has to build and deploy the container. So this time I'll do debug on Kubernetes, and you'll understand why I'm doing this. Because I wanted to show you how to debug, step-by-step debugging. So again, looking at the output, this time it takes a little bit more longer, one more minute I think, because it has to build the application, it also has to connect to the database. So Spring Boot takes a little while to connect to the database and get it ready. Let's give it the time. In the meanwhile, since this is going to run the code on, or expose the code on localhost 8080, I'm creating an environment variable with this name so that we can test it. Let's look at the output. Spring is coming up. Maybe one more minute. Starting. Okay. Let's see. Still not up. Oh, it's connecting to the database. There it is. So the app is running. So what we'll do now is add some data because we did we built a CRUD application. So we'll add a couple of records, couple of items here, for which I am posting. I'm using curl to post 2 records. One is a body spray, other one is a nail cutter. Okay, 2 items with ID 37 and 38 got added. These IDs are assigned by PostgreSQL. Okay, now let's do a get on these items. So let's say items. Oh, it says page is not working. What's wrong with it? Let's figure out. So now that we have running this application in debug mode, and we know that this /items is get mapping, something is wrong with get. Post worked, right? When we did a post, it worked, but the get is not working. So let me figure out what's going on. I'll add a breakpoint here. You see this red dot here? I'm adding a breakpoint. Now I'll refresh this, and it is waiting when I refreshed it. I don't see that it is waiting. Give me 1 second. Let's go back to the output. So you can see that since I'm running it in debug mode, it says it's a debuggable container, right? Let's access it again. So it's on a clock, it's waiting, right? So the control got stopped at the place where we put the breakpoint. The first step here, it's creating a new array list. So let's look at the local variables here. Since the array list is not created yet, this step is going to create it. Let's step over. The next, it is going to connect to the database and find all the records. We added 2 records, so it should result in item size equal to 2, right? So let's do the step over. It went into an exception. What's wrong here? Let's figure out. Look at the local variables here. You can actually see what exactly is happening at that point of time in your code. I'm not sure how many of you have actually used a debugger. So see the detailed message here. It says no default constructor for the entity class com.example.springboot.item. So my entity class doesn't have a constructor. It's clearly telling me what is wrong. If you were a developer, I mean, most of you are developers, if you have to figure this out, how much will you struggle? Think about it. You have some code, you are missing a default constructor, let's say. You'll spend a few days to figure this out, right? But it directly tells you what the error is. Now that we know what it is, right? And this is an actual issue that happened to me while I was writing this code. So I kept the issue as is. I forgot the default constructor when I was writing this code, and it pointed me this issue, and then I went and fixed it. So let's go back and add the default constructor. Let's see, this is item.java, this is an entity file. It has the regular constructor, but it doesn't have default constructor. So let's add it. Very simple change. Public item. That's it. As soon as I make the change, the changes are getting synced, right? Yeah, it is syncing 4 files. Spring Boot is restarting. Okay, it's up. Now if you check, oh, it's still starting. Okay. There is a result. The 2 items are shown, right? So you saw the value of using step-by-step debugging. You saw the value of hot reloading. You saw the value of building containers without getting out or creating Docker files and dealing with all that crap, right? You saw how easy it is to just write the code and immediately see the results on a real production-like environment, right? That's our solution. So I'll stop here. Any questions? Mm-hmm.
Does it apply to just that file, or do you have to keep update all the different files as they are being updated in source control system for each developer? Please repeat the question into the microphone. So, if I understand your question correctly, you're saying that if I'm making a change to an application, will it be limited to that particular namespace that the developer is allocated, or will it apply across all other namespaces? Is that correct? What about the changes that you don't make? The applications you don't change, are those shared between namespaces and kept up to date? No, no. We are now talking about each developer getting their own namespace, each developer getting their own pod. So let's say there are 5 developers working on a team. Each developer wants their own runtime, right? They get their own pod. They are connecting to their own pod. Developer 1 gets their developer 1's pod. They are making a change and testing it for themselves.
This is not integrated testing.
So the things that don't belong in that pod, are those things shared or are those unique issues?
It depends on how you are installing. For example, if dev 1 wants the entire environment, like let's say that he's testing with 10 other microservices. If all those microservices are installed within the same namespace and this pod that the developer is actually changing is connecting to those private pods that this developer created for himself or herself, then it's privatized. But if you are actually connecting to other microservices that are outside and you are sharing between all these 5 developers, then it's shared. So it depends on how you are deploying it. There is no one right way or wrong way. It depends on how much resources you want to consume for setting up all those other dependencies. Any other questions? Yep.
So in a stateful application like you would throw in, like, say, a CRUD app, right?
Mm-hmm.
You have maybe you want your database to be in a certain state for testing, right? Like if you have a set of testing trees or something, you want to be consistent each time you interact with your application, so you're testing the same thing every time.
Mm-hmm.
Does this system have any kind of answer to that, or you still just roll your own?
It is still deploy your own. So you have
So I'd need some kind of script that would go talk to Postgres and dump the table and recreate.
correct. You can actually most of the applications will have their own setup script for your database. Like they'll clean up the database after their job is done, right? And when you are starting your app fresh, it will go and add some records. So since you are still in the unit testing phase, this is not in a higher environment, you would want to clean up the database and start with your own data to test however you want, right? To create the scenario. Yep. All right?
Veer, thank you. Thank you very much. You bet. Yep. So we're going to do this game. Jim, come on up. We're going to switch speakers. I'm going to put the microphone here.
If we had additional time, you would have had a chance to. Oh, sorry.
Yeah. Well, yeah.
You would have had a chance to do this yourself as well, right? But if you are interested in trying hands-on, I know you're not Java developers, Python, Node.js. We do have examples of doing this with Python and Node.js as well. If you are interested, then you can reach out. I mean, for your maybe if your entire organization is interested, we can run this workshop for you and note this email address and send it out. It will come to us, and we can organize a workshop for your request. cdw-request@google.com. Container developer workshop.
And for anybody tuning in virtually, we'll make your slides available. We'll actually send those out to everybody. We'll post those. So this, I think, is your final slide.
Yep.
So that contact email will be included as part of the slide deck.
Yep.
Okay, fair enough. Okay. Veer, thank you very much. Okay, I'm going to ask Jim Salter to come up and go ahead and plug in, Jim. For those of you that joined us virtually on May the 3rd, our last virtual meetup, one of the presentations that we hosted, Souza was one of our speakers, or one of our companies represented by the speaker that we hosted. It was a presentation called Contributing to Samba. If anyone here has ever heard of Samba, yep, it's a Windows interoperability suite with Linux project. Very, very popular, but they actually did that presentation. It was on how to contribute the pieces and parts of the project, right in line with everything that we do. At the end of the day, one of the primary reasons that we started All Things Open and we started hosting these events was really to on-ramp more people into open source and get more people contributing. And again, contributing doesn't necessarily mean writing code. I know that we have a designer here with us tonight. I think she might still be here, but I had a long conversation with her prior to tonight's meetup. But she is looking to maybe contribute, or she does a lot of design work, interfaces with people that write code, more technical people. Those people can absolutely contribute to open source projects. So that is part of the reason that we're hosting this series, is to highlight and spotlight popular open source projects, and then to describe and really show people, demonstrate how you can contribute, what the pieces and parts are of an open source project, etc. We still believe that open source is a great on-ramp into the tech industry. And it's a great way to meet people. It's a great way to, get jobs. It's a great way to market yourself and then just contribute for the greater good as well. But the question that people have often is, well, which project do I contribute to? Where might I find a project to contribute to? And then even when I go to GitHub, how might I make a decision regarding which project I might contribute to? Is it the number of GitHub stars? What is it? Is it just, maybe some chatter? Maybe I've heard about a project, etc. So how do you actually choose a project? So what we're trying to do with this series is to highlight projects that you can potentially contribute to, and then in the process, at the same time, highlight the pieces and parts of open source projects, the problems that they solve, the people behind them, etc. So Jim Salter is a personal friend, a friend of All Things Open. He's been a speaker really since even before we started All Things Open. We were doing open source events even before, 10 years ago, even before we did All Things Open, and Jim was speaking at those events as well. He's a 20-plus year system administrator, practicing sysadmin. He now works for a pretty well-known local company, and prior to that, he was working with Ars Technica. Jim, you were writing some articles, feature articles that some of you probably read. So whether you realize it or not, a lot of you here have probably read Jim Salter's stuff on Ars Technica. So he kind of knows what he's talking about. We like to spotlight him and host him whenever we can. So Jim, take about 10 minutes, talk about Cyanoid, show the project, and maybe give some of the background, ways to contribute, problems that it solves, and things like that. So I'm going to turn this over to you.
Hi, folks. How many folks here are not familiar at all with what ZFS is? Okay, cool. So to understand Cyanoid, you have to at least have a vague idea of ZFS, because everything Cyanoid does orchestrates ZFS operations. ZFS is a really cool next-generation file system that allows you to do lots of advanced things like snapshot the entire file system instantly and take up almost no actual space on disk. And what that snapshot actually is the entire condition of your disk and all the files and data on it preserved until you destroy that snapshot. So that makes it really easy to go and undo really ugly mistakes you might have made, or even malicious things that might have happened if somebody hacked into your system. And a lot of our presentation tonight is going to talk about that. Also, I'd like to apologize a little bit. Normally my presentations are like full-on slide decks, practiced in advance, the whole nine. Do I have any old school UFC fans in the audience tonight? Any? So I guess the reference won't mean anything. This is my Tank Abbott moment. Tank Abbott was a fighter in the very early days of the UFC who, one of the things he was infamous for is if a fighter got injured, you could just call Tank at the bar and he would hop off a bar stool and fly out to wherever the UFC was and fight whoever it was who needed fighting. So this is kind of my Tank Abbott moment. This laptop was brand new as of today. I installed Ubuntu on it about an hour before the presentation. And while Veer was talking, I installed all my software on it and a few VMs. So what we're looking at right here on the screen right now is the GitHub project page for Cyanoid itself, which is the primary place for you to go and either contribute or grab copies of it. Although at this point, do we have any Ubuntu users in the crowd? You can actually just apt install Cyanoid now. We're in the Ubuntu repositories, Debian, Arch AUR, and honestly I've lost track at this point of all the other places you can get it. But the canonical source and where the development happens is here on GitHub. I am going to do I'm just going to play us a video real quick and show you what we're doing, assuming our Wi-Fi wants to cooperate. Oh good, and we have an ad. No, we don't. You can stop now. Come on. Where's the skip? Where'd you go? There we go. Yes, please go away. Thank you. Oh my God. All right. So what we're looking at here is a Windows Server 2012 VM. And we're going to go ahead and infect it with crypto malware, which is always really fun. So this particular variant of crypto malware is not one of the actual nasty ones you encounter in the wild, and the major reason for that is because it's actually hard to find a working copy of live ransomware. because the command and control servers get nuked so frequently. If you didn't harvest it like that day, it probably won't work. I have another demo now that has an actual installation of Locky, but this was the first working thing that I found. It's called Educrypt. And the guy who wrote this, his idea was, if you get nailed by this, it will actually encrypt all your stuff, but everybody has the same key, and he published it. So you can decrypt it yourself easily. He put it out there hoping that people who got infected would learn a lesson from it, basically. So as we're running this, this malware, you can see the disk usage on Resource Monitor spiking way up. And you can see that the icons changed on our desktop because all of our files now have been replaced with little text files that, you know, basically say, you suck, you got infected, you know, don't be so dumb. Now, as I mentioned, this is a virtual machine. This Windows VM is running on top of an Ubuntu host. And what we're about to do now is we're going to drop down to the command line, and we're going to use ZFS and Cyanoid to just roll back the VM and undo all the damage that we just did to it. Now remember, we literally encrypted everything on that VM's drive. So we listed all the snapshots, and you see automatically taken snapshots with date stamps on them, and also a manual one that I took right before I had infected everything. And now we're already done. We already rolled back the VM. Now all we have to do is boot it. And when we log in, you'll note that our icons are back. Our PDFs are PDFs again, and not text files insulting our intelligence. All right. So basically that's enough of that, and we can move on to looking at some more practicals. That text size is probably going to be a little small for you folks, isn't it? All right. Let's bump that up a little. That'll probably work. Yeah, it looks better. All right. So Cyanoid's config files live in etc. Cyanoid, surprise, surprise. And the main one is cyanoid.conf itself. I like to think this is pretty human readable. We have two pools on this machine. A pool is the base level of storage for ZFS. And I created two different pools, one named data and one named backup, because it helps us simulate a little bit the idea of having multiple machines. And a lot of what we're going to talk about is applicable not only for backing things up on this machine itself, but you can also back up very easily and rapidly over the network to another one. Having two separate pools just kind of makes it a little easier to visualize that, since I've really only got the one laptop here. So you can see for each of our pools, we've got two data sets, presentations and images. Images contains all of our VMs, which we've got a freshly installed Windows Server 2019. And you can see for each one of these, we say use template equals production on the data pool, and we say use template equals backup on the backup pool. You don't have to use templates at all, but they make your life a lot easier. We can examine what each template actually means a little further down in the file. We can see that we're taking 36 hourlies, 30 dailies, and 3 monthlies. We're automatically taking snapshots, and we're automatically thinning them when they get stale, you know, meaning they're past the date that we've set with this policy. So like if we say we want 36 hourly snapshots, once we have 37 hourlies and the oldest one is more than 36 hours old, Cyanoid will destroy it automatically for you. Similarly, when we say we want to take 36 hourlies, every hour on the hour we'll take a new hourly. And on a laptop like this machine here, we can also see I am also not used to having to one-hand type while I give a presentation. All right, so we can see all the images, all the snapshots on the machine here, and if you look up towards the top, you'll notice that some of them have kind of weird timestamps. We've got an hourly that was taken at 6:30, not at 6 o'clock. We've got another hourly that was taken at 6:56 and 18 seconds, not 6 o'clock or 7 o'clock. And the reason for that is this laptop was powered off for some of the time today. And Cyanoid is also smart enough to say, hey, if for some reason the last hourly or the last daily that should have been taken did not get taken, we'll go ahead and take one immediately now. But we're not going to push back the time when we ought to take an hourly at the top of the hour or a daily at 11:59 p.m. at night. We're just going to go ahead and take one immediately now because we missed one, and take another one the next time that we really ought to be taking one. So it's as tolerant as it can possibly be of environmental issues and all that kind of thing. And that's so Cyanoid itself is the part that takes and destroys these snapshots for the most part. Cyanoid can also perform some monitoring for you. So if we say Cyanoid monitor snapshots, you'll see it says, okay, all of our monitored data sets, and that's everything that we had in that config file on backup and data both, have fresh snapshots. That means they've got snapshots according to policy. They've got an hourly within the last hour, a daily within the last day, and so forth. Now, those policies are actually a little different for the data and for the backup. The backup will let you get a little bit staler because it can't take its own snapshots. They get replicated in from the production side. And let's take a look at what that means really quickly. So I mentioned that while Veer was talking, I set up a Windows VM on this box. We'll go ahead and start that thing now. Alrighty, so we've got a nice, perfectly functional Windows Server 2019 VM, right? We can log into it, we can look around, everything's fine and dandy. We can also do horrible things to it. One of the things that I like to do to demonstrate the idea of completely screwing up a VM, especially a Windows one, is just delete System32. Unfortunately, there's so many mollyguards on that now that you're like clicking, yes, I really want to do this, and yes, do that, and no, don't do that for like 5 minutes, and then waiting for things to delete. So instead, I did that while we were waiting and took a snapshot for it. So we're going to look at all of our snapshots for the Windows VM. You can see we've got several with timestamps here. These are the ones that Cyanoid took automatically. You can also take manual snapshots, which I did here. And you can see one of these is named @DellSystem32 lol. So that was immediately after I deleted System32 and also the rest of the Windows directory, just for good measure. And so we are just going to roll back to that real quick. Oh. Well, we also need to roll back and not rule back. All right. So we just rolled back, and we actually, that operation, as quick as it was, actually entailed deleting about 10 gigs worth of things that Windows really needed, as we can see. All right, so that was bad. We don't like that. Now, what we could also do, we could just roll back one further. So we've still got our gold snapshot before that, and that was when Windows was all set up and before I did something horrible and stupid to it. But we've got another option, because we've got that backup pool and we've been replicating to it. So we're going to look at backup images Windows. And you can see we've still got all of our snapshots there. So we're going to use the other half of Cyanoid, which is an app called Syncoid that automates ZFS replication. And we're going to pull that Windows @recovered snapshot back onto the production side. And we're actually going to get a little bit fancy with that. So the ZFS veterans in the house, I know we've got a few, are aware that you can use Syncoid and ZFS replication, but normally you got to be root for that, right? So this is kind of a little bit of a permissions problem. If you're actually replicating between machines, you end up publishing root keys. So if you compromise one of them, you've really fully compromised the other one if you have any idea those keys have been published. But that's no longer something that you absolutely have to do. So what we're going to do is we're going to demonstrate privilegeless replication instead. Okay, so now I'm logged in as the receive user. The only permissions I really have here are what's required to receive incoming replication. I can't even look at the contents of my data folder. If I try, I get permission denied because I have no privileges whatsoever. But what I can do is syncoid send user. I've got another unprivileged user who only has the privileges needed to send data sets. And I'm going to go from my backup pool, images, windows, to my production pool named data. And that's going to get me that @recovered snapshot back, which is where I want to be. As I mentioned, this is actually quite a bit of data because basically the only thing on that VM is the Windows directory, and I deleted all of it. So we are going to recover about 10 gigs worth of stuff here real quick. Maybe I should have deleted slightly fewer files instead of going for the overkill. Okay. 3, 2, 1. All righty. So now, if we look at data images windows, we can see that we have that @recovered snapshot back. That also means that the condition of our live file system on data images windows is the same as it was in that snapshot. And what that means in practice is that now the moment of truth. Do we blue screen? And of course, we do not, because we recovered from the horrible things that we did. So this is basically what Cyanoid is really all about. And it doesn't have to be about VMs. There are lots of, I mean, there are at this point tens of thousands of people using this software just for like regular files, you know, the stuff in your user folder, your pictures, your Word documents, you know, your whatever. I work with VMs a lot, and VMs are traditionally one of the biggest pains in the butt to back up quickly and reliably. And as you can see, this is kind of a game changer, especially, you know, if you're not going to spend thousands and thousands of dollars of licenses on VMware and Veeam and everything else. And even if you did spend all that money, frankly, this works better. It's quicker. All right. So we have seen a practical demonstration. We've seen the code. We've seen Cyanoid can also monitor the health of your pool. So on this particular laptop, our storage is ridiculously simple. Our pools are actually just files on the drive, but normally you would have multiple disks involved in each of your pools. And if you lose a disk or you get errors or whatever, this monitor health right here will check all the pools that Cyanoid knows about, and it will let you know what's going on. Now you may notice that both monitor health and monitor snapshots started out with an OK here. That's because there are 3 conditions they can return: OK, warn, and crit. And if there are any monitoring gurus in the house who've used Nagios, that might sound familiar. And that's because both of these modes of operation function perfectly well as Nagios plugins. So in my real infrastructure, I actually have this tied directly in. And if I stop receiving snapshots on a backup server, or if I throw a disk on a server or whatever, I'm actually going to immediately, my phone is going to start blowing up in my pocket and irritate me until I go and figure out what's going on. So rather than having a really unpleasant surprise when I come into work on Monday, I have a really unpleasant surprise at 8:30 on a Saturday night. But at least I know what my Monday morning is going to look like. All right, so we're about out of time here, but pivoting back to the GitHub page for a second. I'll just mention, so Cyanoid is written in Perl, which I know is kind of an odd choice in 2022, but like Todd mentioned, I've been a system administrator for a very long time, and It was a good language. We've got quite a lot of contributors. At this point, we have 2.2 thousand stars, 234 forks. When I first developed this project, it was literally just me out there putting it on the web, and I'm still kind of haven't gotten used to the idea that I have an entire community out there. We have got a lot of active development, and I have written almost none of the new code in about 2 years, which is pretty amazing for me to have graduated from reluctant coder to reluctant manager of coders. So that's about all I've really got for you tonight. Like I said, I apologize. Usually I got a much slicker, more prepared presentation. This is what I could do with like half an hour worth of notice. Does anybody have any questions they want to ask? Bueller? Yep, yep. The question was, how long does it take to spin up Cyanoid on a new system? And like, if you were installing Ubuntu server from scratch, your first step would be apt install zfs utils-linux to get ZFS itself installed. Your next step would be, if you want to go the package manager route and be, use a little bit older version that has made it into Ubuntu's repos, although they're all quite functional. You can literally just apt install Cyanoid. It's instant, it's installed, and you get a demo version of the config file that you saw that you can very quickly edit into exactly what you want. The templates that you saw are already provided. They're already there. They can be edited, or you can use them as is. So there's basically almost no donkey work involved. You can be up in seconds. If you want the latest version, I actually don't have an installer on GitHub because, again, it's just Perl scripts. There's like 3 of them to fetch and dump into user local bin, which is actually how I do it on my systems. I've actually, on my server, I've got a little lazy short link that goes directly to the raw on the master on GitHub, so I can just wget Cyanoid from my server, and it will get whatever the freshest is from the repo, because I'm pretty picky about what goes into the master. Obviously, if you're trying to have the most stable system, you probably shouldn't be fetching things directly from master on somebody's GitHub. But I generally don't accept a pull request until it's been pretty well tested, and I'm pretty sure it's not going to cause anybody any serious problems. So it's usually pretty safe to use. Now, you can also, of course, obviously, we have proper releases, and you can just click straight to the release page and know exactly what you're getting and grab it that way. Anybody else? Thanks, folks.
Okay. Jim, thank you very, very much. Okay, does anyone here use WebAssembly? WebAssembly at all? I actually have a book, The Art of WebAssembly. Peter made this book possible, and he made this available. That's Carl? Yeah? Okay, very good. You want me to wait? How about Stella? How about this? How about we do a handoff? Fair? I don't trust my throwing accuracy, frankly. I don't want to knock somebody out with a book and then be held liable. That'd be awful. Be a bad way to end your night. Okay, so for everybody watching virtually, I want to thank you all for your patience. Thanks for staying with us. Our next meetup in Columbia is going to be next month. It's going to be, off the top of my head, I think June 21st, which is a Tuesday. It'll be right here. Garth Henson from Disney Streaming will be joining us. Those of you that have attended A2 events before, you might have seen Garth. Garth is a multi-time speaker for us as well. He lives in the RTP. He's going to be making the drive down from the Research Triangle Park to join us here. So by all means, please join us. And then we'll be, our next meetup, our for real next meetup in person, will be in the Research Triangle Park in about 2 to 3 weeks at the Carolina Theater in downtown Durham. So anyone here that wants to travel to the Research Triangle Park and join us on the ground on June the 14th, I would encourage you to do that. That's our next meetup. And then I would encourage everyone on the 21st to join us right back here as well for Garth Henson with Disney Streaming. Garth is a fantastic speaker. We have Peter Zetsef. Peter speaking at the one in Durham, coming up next on the 14th. Those of you who may not know, Peter is CEO of Percona. He's an extremely well-known international technologist. He's an author. He's written a lot of popular books, et cetera, et cetera. Peter's also been a speaker here at Open Source South Carolina. Some of you might have met Peter and maybe even gotten a book signed by him and from him when he spoke here maybe 2 or 3 years ago. Anyway, I want to thank you all for joining us. Final thing I promise, I want to thank sponsors again for making this possible. I want to thank our crew, Brandon and your team. Thank you for live streaming. Thank you for setting up. We are going to be recording, or we have been recording tonight. So this recording of both talks will be available on our YouTube channel, hopefully by the end of the week. We're going to move as quickly as possible. Also want to direct you over to the swag table. In addition to the shirts and the hats, I would encourage everybody here to grab something. We've also put some technology out. We have some wireless routers, some mesh routers, some et cetera. Jim Salter has made those items available. Some of them, Jim, I don't know if you want to explain this, or maybe I'm going into too much detail. Some of it is new, some of it is not new, slightly used. Jim, when he was with Ars Technica, would review products, would review items, and so he would test them. So very, very lightly used on some of the stuff, but it's still almost brand new. And I would really like for someone to get some use out of it. It's super nice stuff. Jim, do you have anything else to offer?
If you pick up something that doesn't still have actual cellophane shrink wrap on it, you may want to have a paper clip handy. So basically, anything that doesn't still have the shrink wrap on it has been tested at ours. So it has got some username and password on it. It's already been set up. Unbend a paper clip, jam it in the hole, and it's good as new again. None of them have been used beyond a few hours for testing.
All right. So as opposed to ditching it and kind of, disposing of it, that makes no sense to me. Somebody needs to get some use out of it. So grab a T-shirt or grab a hat, grab stickers, or grab some technology over on the swag table, okay? I want to thank our host. I want to thank SOCO. Is Hannah still here? I don't see Hannah. Maybe she's outside. Oh, she's coming in right now. I do want to thank SOCO. For all of us watching virtually, right, for everyone joining virtually, if you're in Columbia, South Carolina, I would encourage you to stop by SOCO. They have day desks available. They have monthly, contracts available. It's a basic co-working space. It's wonderful. It's right at downtown in the entertainment district. It's perfectly located, in my opinion, and they really do a great job here. The team here is super nice, Greg and his team. And Hannah, thank you for your help tonight. I do want to thank you all. So for everybody joining virtually and everybody in-house here, thank you all again. Hope to see you in 2 weeks or maybe 3 weeks back here. And then virtually, we're going to announce some additional virtual meetups very soon. We are going to, final thing I promise, we're announcing and launching All Things Open 2022 in about 2 weeks. So we're going to open up registration for that event in about 2 weeks. I know I said that before. We're going to launch the new website, so you'll have a chance to see the design. You'll have a chance to see the speaker lineup. We're going to announce the first 50 speakers. I think you'll like what you see when you see the speaker lineup. Okay, I'll just say it's solid. We've been working for months and months on the speaker lineup. A lot of the speakers that you'll see, they're eager to get back in the game too. They've been offline. They've been off the grid for 2 years. They're eager to do in-person events again. And then this is also our 10-year anniversary. It's year number 10 for All Things Open. So I think a lot of the speakers wanted to be a part of that event as well. So I would encourage you, be on the lookout. We'll launch with an early bird registration special. And then we also make scholarships available as well. So check out the scholarships. They'll be clearly listed there, and they'll be clearly explained if you don't have the money. All of our tickets to all of our shows are very, very inexpensive. All of our meetups are free. Open Source 101 is free. And for All Things Open, for the entire event, and it includes lunch, it's $99. So we think for under $100 to attend a 2-day conference that includes a boxed lunch, it's pretty good. It's not bad. We think it's very, very fair. But if that presents an issue for you, please let us know, okay? That's why we make scholarships available. We have never in the history of ATO turned an individual down that could not afford to go. We have always found a way, and they've always been able to attend. So we don't want to know why. We don't want to know the story. It's not any of our business. It's called a Catch Us Next Time scholarship. And, take us up on the scholarship offer this year, and then down the road at some point, if you can afford to pay or if it's easier for you to pay, then just pay then, okay? Is that fair? Any questions before we break and call it a night? I want to thank you all one last time, for the 10th time at least, for joining us tonight. If you have any questions, find me after we wrap up here in just a second, and do make your way over to the swag table, okay? All right, Stella, bye. See ya. Okay. Thank you all.